Hi students, all of you welcome. Students, in the previous session, we have completed 20 previous year questions. In this session also, I want to discuss another 20 questions which asked in RRB electrical examination. Okay. So all this we have completed. If you want, you can watch in this YouTube channel. Yes. So up to this one we have completed. Now coming to the first question, guys. In the torque load characteristic curve of a DC series motor, what happens as load increases? What happens as load increases? We know very well the torque PS load. Okay, we know torque is proportional to current square of the current, correct? So in the DC series motor, torque is proportional to I square. So here the torque increases proportionally to the square of the armature current. To the square of the armature current. Here in the series motor, load current is equal to armature current. Both are connected in the series. So you can say torque proportional to I square. Or if you take it is a load IL, or if you take it is a armature current IA. Coming to the next question, Fleming's right hand rule is used to determine the direction of dash. In the previous session also we have discussed this type of question. We have Fleming's left hand rule, Fleming's right hand rule. Okay, so here L, here R. So what is the simple trick to remember? R. R for generator. In the generator we have two R's are there now. So R is the domination. So in the generator, right hand rule. What is the output of generator? Generally you can say voltage or EMF. So EMF. So EMF direction. So it will give the direction of EMF. Okay. EMF in the sense electromotive force. So here the answer is option 2. In the left hand rule, that is motor. In the motor, what is the output of the motor? That is nothing but force or direction of rotation. Direction of rotation. It is given by Fleming's left hand rule. Okay. Coming to the next question. In J notation used in phasor representation, the imaginary unit J square represents dash. We know very well J, sometimes we use the notation J, sometimes we use the notation I, whatever it may be. Here it is I square or J square is represented as -1. Represented as -1. So the answer is option 1. Okay. So coming to the next question. A power system with a high reactive power demand will result in dash. High reactive power. So when we will get high reactive power, it is nothing but if it is a inductive, then we can we have it demands high reactive power. Am I correct? So that means inductive in the sense the power factor will be low power factor. So whenever they have given high reactive power demand, that is it will be a low power factor. Low power factor. Okay. So we know very well the power factor. So the power factor for resistive circuits, it is maximum, that is 1. So for resistive circuit we have only active power. We have only active power. And for inductive circuit, the power factor is, for pure inductor you can say the power factor is 0. Okay. So that means for reactive circuit, the power factor is always very low. So if it demands high reactive power, then power factor always less. Coming to the next question. Which factor does not affect the starting torque of an induction start synchronous motor? Induction start synchronous motor. That is for starting of synchronous motor, we use a pony motor. That is nothing but a small induction motor. In that case, which not affect, okay, which not affect. Here, in case of if you are starting with induction type motor for the starting of synchronous motor, it is not at all depend upon field excitation during the startup. At startup, we are starting with external motor. So why it depends on field excitation? There is no depends. So the answer is option A. In a power triangle, what is the relationship between active power, reactive power, and apparent power? So we know very well active power always like this, and reactive power having 90 degrees angle with the active power. So the resultant is nothing but apparent power. So it is the active, you know very well, reactive, it is the apparent. So then what is the relation? S square is equal to P square plus Q square. So S is equal to P plus JQ now. P plus JQ. So square it, S square is equal to P square plus Q square. Nothing but Pythagoras theory. Okay. S square is equal to P square plus Q square. So the answer is option D. Coming to the next one. In series RLC circuit, the total impedance is minimum when dash. The total impedance is minimum dash. So whenever XL is equal to XC, what will happen? It will be under resonance. It will be under resonance. Then total impedance is equal to resistance only. Resistance only. So when it will happen, whenever the XL is equal to XC. So Z is equal to R plus J XL minus XC. Okay. Whenever XL is equal to XC, what will happen? Z is equal to R. That will be minimum only. Minimum only. Okay. It is the condition of resonance. Coming to the next one. What is the main drawback of using an induction generator in a grid connected wind turbine? So we know very well induction or inductor, it demands more reactive power. Correct? It requires more reactive power. So it requires external reactive power from the grid. Okay, it always draws more reactive power. Coming to the next one. Read the given assertion and reason carefully and select the correct option. First assertion. The burden of an instrument transformer is usually expressed in volt amps. Very, very important point, guys. Very, very important. It is true. Instrument transformers burden of instrument transformer is expressed in VA, volt amperes. Directly they will ask the question. And here the reason, burden is the total impedance of connected devices including meters, relays and wiring. So it is also correct. Statement A correct and statement R is also correct, but there is no relation between these two. So both are true and R is not the correct explanation of A. Okay. What is the first step in the design procedure for electrical installations in commercial buildings? What is the first step? First step, we have to conduct the load analysis. Then only we can get our requirements. What is the power requirements? So conducting load analysis to determine the power requirements. That is in that commercial buildings, we need to check how many fans we require, how many bulbs we require, what are the required geyser capacities, and we have to add all those, and we have to take some higher, okay, higher ratings. Which connection method is correct when using a CT and PT, current transformer and potential transformer, with a wattmeter? We know very well current. So whenever we have CT, current is in series, always series. Correct? Potential voltage, it is always parallel. Okay. So CT is always connected in series and PT is always connected to parallel with the voltage kind. So the answer is option A. So here it is the current transformer. It is always connected in series with the load, and the potential transformer here. Okay. So it is always parallel. Okay. When armature conductors carry a lower load current, the armature's MMF causes dash. No effect on the main field flux. The main field flux strengthen and increase in the induced EMF, a cross magnetizing effect. Here, what will happen? Here, we have the concept that is nothing but armature reaction. What is the armature reaction? The armature reaction in the sense the armature flux and we have the field flux. The effect of armature flux on the field flux is nothing but you can say armature reaction. Am I correct? Okay. So the effect of armature flux on the field flux is nothing but you can say armature reaction. So due to this, what will happen? There is a cross magnetization effect. So answer is option A, cross magnetizing effect. Okay. Coming to the next question. And in DC generators MCQ series, I have explained in detail about armature reaction concept. You can listen that sessions. You will get a clear idea. Here, just a practice series, na. So we need to complete these questions within less time. Winding in wire wound resistor is made up of dash. In wire wound resistors, generally we use the material nichrome. Nichrome is the it is alloy. It is the combination of nickel and chromium. Nickel and chromium. So it can withstand for very high temperatures. Okay. So those are these wire wound resistors typically made with the type of material is called as nichrome. Nichrome is in the sense nickel chromium alloy. Okay. Because of its very high resistance, it can offer very high resistance and also stability. It will use the very good stability for temperature variations. Here we have this wire wound resistors. Okay, has high resistance and stability under various conditions. Means temperature, pressure, and all those. The luminous intensity of a source emitting light uniformly in all directions of 10 lumen per steradian is dash. Lumen per steradian is nothing but candela, na? One candela is equal to lumen per steradian. Correct. So they have given lumen per steradians are 10 means 10 candela. A very easy question. Okay, candela is nothing but lumen per steradian. So they have given 10 lumens per steradian in the sense 10 candela. Shaded pole motors are ideal for dash. So remember one important thing, it is a very important question on shaded pole motors. These shaded pole motors always for low speed applications. Low speed applications. So low speed in the sense they have low torque. Okay. So whenever they have low torque, we use them for which requires lower power. Okay, low power. So it will use for low speed applications or low starting torque applications or low power applications like personal computer fans. Very important question. In PC fans, which type of motors are used? Very shaded pole. In case of blowers, okay, in case of timers, in case of hair dryers, in all those use the shaded pole motors. They have low torque. Okay, and low torque, low power in the sense those design also very easy and low cost applications also. For very less cost, which type of motors are used? That is nothing but shaded pole motors. Okay, for a PN junction diode, as the temperature increases, what happened to the forward knee voltage of the diode and the reverse saturation current? We know very well PN junction diode characteristics. Here we have, this is the forward characteristics and this is the reverse characteristic. Okay, here we have the new voltage, generally 0.3 or 0.7. Okay, so whenever the temperature increases, what will happen? The new voltage is going to be reduces. New voltage is going to be reduces. So we have the two options. And what about the reverse saturation current? Reverse saturation current depends upon the temperature. As temperature increases, reverse saturation current, that is nothing but leakage current. Leakage current also increases. So increases, we have only one option. So the answer is option A. Okay. So here the voltage for low voltage also it is going to be conduct in the that is in the forward bias. Okay. In case of reverse bias, we have the leakage current. That is generally reverse bias in the sense it is forward bias for minority charge carriers. Okay, as temperature increases, then minority carriers will be increases. So the current will be increases. So the answer is option D. Coming to the next question, a very good question. If a Laplace transform of voltage across the capacitor value is 0.5 farad, capacitor value given 0.5 farad. Okay, and Laplace transform of voltage across the capacitor. Here Laplace transforms given Vc of S is equal to 1 by S square plus 1. If you convert into time domain, that is if you go with inverse Laplace, then Vc of t is equal to 1 by S square plus 1 means sin t na sin t. If you differentiate with this, dv by dt is equal to differentiation of sin t is nothing but cos t. So capacitor value given means we know very well current through the capacitor I is equal to C dv by dt. Okay, so they are asking current na. So current in the sense C value is nothing but 0.5 dv by dt. We got cos t at t is equal to 0 plus they are asking. So that means here I is equal to 0.5 into cos 0. Cos 0 is equal to 1. So I is equal to 0.5. So the answer is 0.5. Yes. So answer is option B. So answer is option B. Okay. A very easy question only. Just we know the formula I is equal to C dv by dt and inverse Laplace, and we can get the I value. Identify the correct statement related to switching speed of the BJT. Switching speed of the BJT. Here, the switching speed of the BJT is less while compared to MOSFET. Here we have both carriers. Here we have FET in the sense only majority carriers. So the switching speed will be very high than the BJT. In our notes, I have given switching speed of BJT is the correct one, right? Yes. Coming to the next one. The eddy current loss in a transformer is caused by dash. Eddy currents. Eddy currents are nothing but circulating currents. Circulating currents in the sense answer is option D. Circulating currents in the sense answer is option D. 0.5 ohm shunt resistor is used to measure current with a CRO. If measured voltage drop is 5 volts, what is the current? Current I is equal to voltage by resistance, 5 volts, 0.5 ohms. So that is nothing but we can say, what is the answer we have? 5 by 0.5 means 1 by 2. That is nothing but 10 amps. So answer is option 2. Okay. Answer is option. So all the questions are very simple only, but a simple understanding is required and practice is must. Okay. So to get the RRB JEE job, that is very easy only. For that you need to do a constant preparation, okay, and practice. Then we can easily get the job. That is nothing in this. Okay. Okay, students, we will discuss the remaining questions in the next session. And if you want some other stuff, you can click on the playlist and you can find out previous sessions. Okay, and if you want any material, you can visit sunilengineeringacademy.com and you will get that link in the description. And you can click and you can get the PDF also. Okay, okay, students, thank you so much for watching. Take care. Bye, guys.